Hi, this is Christopher Boucher, and I'm going to review how to perform a simple sample standard deviation calculation. Okay, we'll get started. Okay, Joe's high flow shower heads sample standard deviation. This is the name of the problem. So I'm going to be using the squared deviations formula, and there's two different types. They both come to the same answers. It's just a matter of kind of what steps you do your work in. Okay, Joe's High Flow Shower Heads specializes in California illegal high water volume shower heads for the customers who like a deluge of water when taking a shower. Below is the weight in pounds of 6 high flow shower heads with install kits included. Install kits Joe sells from a catalog of thousands. Okay, so here are the weights. That must be some really heavy shower head and install kits. So 95 pounds, 75 pounds, 83 pounds, 75 pounds, 68 pounds, and 80 pounds. Okay, and it says, what is the sample standard deviation of the 6 high flow shower heads with install kits? Okay, so this is for sake of simplicity, this problem, number one, we have a sample of only, was that 5? 6. 1, 2, 3, 4, 5, so yeah, 6. So we have a really small sample. So this isn't ideal in the real world, and later in some of my other videos we talk about data being normalized and things like that, but with 6 it's a little bit of a small sample. It's also simple for you to learn how to do this by hand. Even though most people do it with the calculator, it's good to at least understand the way this works. Okay, so what I did was I wrote down a lot of the pieces of this problem. I'm gonna scoot up. A lot of the pieces of the problem that we already know in advance without doing any calculations, just to make it easier on everybody trying to read my handwriting. So let's take a look at a couple of these things. These numbers right here, these six weights, are right here. These are our observations in our sample, our 6 weights. So one of the things that we have to do right off the bat is we have to get the sample mean, because when we talk about standard deviation, it has a lot to do with the standard deviation away from the mean of what you're working with. Now this is a sample, so we're going to use the sample formula. And with the sample formula, and I just have just the -1 here written out here, but I'll show you how this fleshes out. We end up using a subtract 1 in our denominator. So I'll show you where that fits in. If it was population data, we wouldn't be subtracting 1 from our n when we do this calculation. So let's take a look. Okay, so here's all of our data right here. So we need to calculate the mean. I usually calculate the mean really early because everything has to do with the mean in this case. Okay, so if we look at the sum, this is our summation symbol, so sum all of our data. The calculation for summing all of our data is, let's see, 476. Okay, 476. And so what we would do 476. And then we go to get this mean, we divide it by the number of observations. So we have 6 observations. Okay, and when we divide this, we end up with our mean for this sample of 79.333. We could go on further, but about 79.33 and a third. So it's important that we get this right because we're going to subtract it from each observation, and that's the beginning of figuring out how much of a deviation each observation is from the mean. So what we do is we put in, right here, we're going to subtract, and I'm just going to put it in real quick, 79.333. So 79.333, 79.333. Like I said, I'm using the square deviations formula. I like it. I believe it's easier. Some people may not. But when you're trying to teach people how to do a standard deviation, I think it's easier to teach this one. Just my opinion. The direct formula will give you the same answer, of course. So yeah. Okay. So now what we'll do is we're going to subtract our sample mean from the observation for each one. And I already have this calculated. So this one is 15.667. I typically don't round, but I usually go out 3 or 4 decimal places. This is negative 4.333. And then the next one is 3.667, and then negative 4.333, and then negative 11.333, and then the last one is just 0.667. Okay, that's a negative. That's a negative. That's a negative. Okay. Okay, so now what we're going to do. So if you think about this, we subtracted the mean from each observation, and that's fine. Now, if we just went and we added up the differences of the mean from each observation or each kind of data point, each weight, then it would balance out. So we wouldn't really have the actual deviation because it balances out. Some are high, some are low, and that's kind of what the average does when we calculate that anyway. So that doesn't work. But what we can do is if we get rid of the negatives, so if we get rid of the negatives, we actually see what's more of an absolute value, absolute difference, we could say. Not to be confused with mean, like absolute difference type of thing, which is a different calculation. But so if we go and we square our results right here, square what we got, then we end up without the negatives, because if you multiply a negative by a negative, you have a positive. So if we square these values, we'll get rid of the negatives. We make them more positive. Get rid of the negativity. Okay. So 2, 4, 5, 4, 5, 4, 8. The numbers get big. That's a problem, isn't it? You'll see what we do. 7, 7, 4, 8. Okay. And then the next one is 13. 13.446, and then 18 should be the same as the other one. Yeah, 18.7748. Yep, and then 128. When I have a lot of number writing to do, sometimes I use the pen instead of the Sharpie, just because it's a little bit easier to read it when we're in tight spaces. So that was 128.4368, then 0.4448. Okay, now we have these large numbers because we squared the differences of the mean from the actual value. So to get rid of or I would say, you'll see what we're going to do. So we go and we add all these up, and I already worked this out. So it ends up being 4, 2, 5, 3, 3, 3, 3. Okay, but so we have this huge number here, and that's fine. So now we go, I'm going to write this right here, 425.3333. And the regular formula has this value. This is the part that we're at right now. The regular formula would be like this. Okay. And actually, the whole thing is like this. Okay. So we've calculated out this center part. Okay. So we're going to we need our n over here. And our n is the number of observations, which is 6. So we put a 6 right here. Okay. Okay. So now what we're going to do, we subtract 1 from our 6, we get 5. And then we go and divide this out. So we go and we divide this out, and we end up with about 85.0666. Okay. So this number right here, 85.0666, not a good number, is it? So this is actually our variance. Now this is a squared value. So this right here is squared because what we did was we went and we got the differences, and then we squared the differences, then we added them up, and then we divided it, but we're still working with a squared result. So the number's really big. So this is our variance. So if we need the variance, we can do that. Now, most people don't like to work with the variance. Some people do. There's pros and cons, but most people want the standard deviation. It's a little bit easier to understand and work with. So what we do is we take this variance and we get the root. So we do this. And that's the putting the hat right there. So we take this. And once we figure that out, we will have our standard deviation as our answer. So 85.0666, and the answer is our standard deviation. That's the variance. This will be standard deviation 9.2231. Okay. I usually do triple little lines underneath sometimes when I want to show the answer. So the answer is, for the sample standard deviation of 6 high flow shower heads with insulation kits, is 9.2231 pounds. If we were working with pounds, I believe, yeah. So we'll say LBS, okay? So we always want to go and put it in a term so that we understand what the answer is, and we say, well, the standard deviation of these high flow shower heads is about 9.2231, or almost, well, about 9 pounds actually. So the kits kind of have some differences in there with their standard deviation and how much they weigh. Okay, and thank you for watching. I hope you learned how to do the standard deviation by hand if you need to.